Hi, everybody. We're on the second section in the number sequences, which is section P for Algebra 1 IXL, and it's arithmetic sequences. So I suspect that they're going to ask us to fill it in. I don't think it's going to have the formula yet, but we'll take a look. I haven't previewed it, so be a surprise. Let's take a look and see what we got. So we're looking for a missing number in the sequence, and I'm assuming that they're always going to be geometric, or rather arithmetic sequences. So it looks like we went up 9, and so we should probably go up 9, which is going to be to 43, and that's going to put us at 52, isn't it? And then the next one is going to be 61 and so on. So it looks like we're looking at 43 right there. We're looking at arithmetic differences here. So we're looking at number differences like subtracting and adding. In this one, it looks like we have an 8, 10, 12, 14, 16, 18, and we are adding 2 every time. These are even number sequence, which is 8 and 14. We're just looking for patterns, always looking for patterns. Let's see, 2014 went down 6. And if we go down 6 more, we're going to be at 8, and then we're going to be at 2, and then we're going to go down 6 more, and we're going to be at -4. So it looks like we have 8 and -4. I guess I should write the -6 right there and the -6 right there and so on. I'm just subtracting 6 each time. I'll try and make it a little easier to see next time. Okay, in this one, how do you get from -13 to -10? And think about it for a second. And we're doing this by adding a number. I'm always going to talk about adding a number, even if it's a negative. So sometimes you're going to add a negative number, sometimes you're going to add a positive number. In this case, we added a +3, and we added a +3, and we added a +3. And clearly, we continue to add positive 3s. And of course, if you add 3 to -1, you get 2. So our missing number there is 2. And if you add 3 again, you get 5. So you can check it too. All right, looks like we need to go for this one. We added -9, didn't we? And we added -9, and we added -9. So if we add -9, we get 4 in the middle there. And sure enough, that's the right answer. Sometimes you got to look a little past and come backwards. Now, we could have done this backwards, but I think it's better to do it in order of the way it's supposed to be. Now, one of the things you'll notice is that we did a -10 right there, didn't we? We added a -10 or subtracted 10. So this one's going to be 67, and this one is going to be 37. And you can see that the 7s line up and that it's definitely the pattern. So we have 67 and 37. Just looking for patterns, that's all. Now in this one, down by 10, down by 10, down by 10. So this one must be 54 and 64. Uh-oh, decimals. 3.6, 3.8, I'm guessing 4.0 and 4.2, and 4.4 and 4.6, yep. Notice that I am adding 0.2 each time. So we have a 4, and we probably are supposed to put the 0.0, I'm not sure, and 4.2. Well, I put it because since they have the decimals on the others, it probably wouldn't matter one way or another, but I like to be consistent. Oh, man. Okay. So this one added 0.4. Sorry, 0.2 again, isn't it? It's a little harder to see that when you go back, you have to subtract 0.2. But what we could do is we could go 0.2 here is 1.02. And then we add 0.2 more, and then we add 0.2 more, and we get the 1.42. in some ways, I would say it's okay to go ahead and do the subtraction, but it's better to think of it in terms of the direction it's going in. So we're talking 1.02 and the 1.42. Sorry, I'm not reading these decimals exactly the way they should be read, but that's all right. All right, so it looks like from here to here, we went up 0.05, didn't we? Can everybody see that? If you take 4.26 and add 0.05, I thought I better show this because some people are going to get lost there. That's going to be 1, carry the 1, 3, and a 4.31. So this is what we added. So in order to add 0.05, make sure you can add it, you add the hundredths place. This is called 5 hundredths instead of 0.05. And if I add 5 hundredths, I get 4 and 21 hundredths, don't I? And then when I add the 5 hundredths, I get to here. And when I add 5 hundredths to this one, I get 4.36. And then when I add 5 hundredths, I get to there. So we're going from here to here, and this time we're adding 2 hundredths. And to get from here to here, we're going to add 2 hundredths. That's how you say that, with the TH at the end. This is what I'm saying in hundredths. And that is 2 hundredths that I added. So I have 3.39. And in this one, we're going to get the 3.45, aren't we? No, yeah, 3.45. And there we go. Okay, this one's not so bad. Looks like we're adding a quarter, 0.25, huh? 0.25. That's a quarter, guys, if you look at it. And we added it there. We added a quarter. I'm going to make sure that that's correct. Yes, we did. And we add another quarter, and we're going to be at 1.46. And we add another quarter, and we're going to be at 1.71. And if we add another quarter, we can check it, 0.25. And sure enough, we're going to be at 1.96. Oh, fractions. Okay. Interesting. It really helps if you have common denominators. Common denominators just make your life so much nicer. And I think you're going to see why I like common denominators in this case. Now I'm going to go ahead and write the 4/5 with a common denominator. And what I'm doing is I'm multiplying by 1. For those of you who don't remember common denominators, I'm going to change this by multiplying by 4 over 4, which gives me 16 over 20. And the same for the 1/2, but this time I have to multiply by 10, don't I? Because I want to get 20ths. So I have to multiply by 10 in the denominator. I also have to multiply by 10 in the numerator. That's 10 100ths. Now, what I want you to notice is that when I write these with a common denominator, I have 16 over 20, I have 13 over 20, I have 10 over 20, I have 7 over 20. And I think you guys can see how much easier the pattern is to see here. Now, some people are going to grab their calculator and try and figure it out that way, but it's so easy to see that we're just subtracting 3, aren't we? Now, there is the problem with that when we get 4 over 20, we do have to reduce it. We did subtract 3 from the numerator each time. We're literally subtracting 3/20ths every time, by the way. If you were to change these to decimals, it would work, but they're actually asking for fractions. So it's a good idea to do fractions. Now, in order to simplify this, we divide by 4 and divide by 4. You could do 2 and then divide by 2 again, but 4 is the largest number, and you do get 1/5. Um, I think I'm just going to go ahead and leave it like that. We could change these to decimals, by the way. This would be 0.8. This would be 0.65 or 0.80 if you like. This one would be 0.50. This one would be 0.35. And what you can see is that we're going down by 0.15 each time, which is 3/20. Some people like decimals better. And that would give you 0.20. The problem, of course, is that you would have to change to a fraction anyway. So whichever makes more sense to you is fine. All right. Looks like we're talking about eighths. So I have 2/8, 3/8, 4/8, 5/8, and 6/8. Of course. But remember, we do have to simplify our answer. So we're dividing by 2 on the top and bottom. Again, you could do decimals, but decimals would not be the way to go here because it looks like we're adding 1/8, which is 0.125. It's going to be pretty ugly decimals to be adding in your head. I would say this would be the way to go. So we're talking about reduce this 6/8. It's going to be 3/4, isn't it? Oh, 1, 3, 5, 7, 9. We like it when it works out nice, huh? Okay, we need 20ths again. So we're talking about 6/20. And then these are 20ths, 5/20, and 4/20, and 3/20. And who is next? And I'm gonna guess that you guys can probably tell it's gonna be 2/20, and we have to simplify it to 1/10. Hopefully I'm not going too fast for you. I'll maybe slow it down on the next one. Oh no, you can do this one. Look at that. 12 to 10, 10 to 8, 8 to 6, and 6, we're subtracting 2/17 every time, aren't we? That's our change each time. That's our arithmetic change. And later in this section, I suspect that we're going to be doing the formula, and it's gonna have a little formula, and we're gonna have numbers that are gonna we're gonna do the first one and the second one and so on. But in this one, the next one is 4/17, of course. Again, we're just looking for the pattern. Oh, 49ths. Well, let's not worry about that one for a second. Of course, that's going to be 28/49ths. 4/7. I'm going to show you what I'm doing. I am changing it to 49ths by multiplying by 7 in the numerator and the denominator. That's 28/49. And 30, 29, 28, 27 gives us 26 for our last one, 26/49. And it looks like you might be able to reduce it, but you can't. The only numbers that go nice or that are factors of 49 are 7. 1, 7, and 49. That's it. And there's no way one of those is going to go into 26. 26 is 2 times 13. So uh, these are not prime numbers, but they're called relatively prime. And the reason is because if I take the prime factorization at the top and the prime factorization of the denominator, there are no prime factors in common. So we call these two numbers relatively prime, and they can't be reduced. Way more information than you wanted, sorry. 26/49. Just can't help myself. Want to teach you some math along the way. All right. Oh, we've got 3/22s and 6/22. Notice that I doubled the numerator and denominator in that one. And then 9/22. And you probably can guess that we're going to get 12 over 22 next, because looks like I'm adding 3 every time. And sure enough, I do, if I double both of those. And can you see what the next one is going to be? I'm going to add 3 again, 3 over 22 actually. And I'm going to get 15 over 22. And again, this is relatively prime. The numerator is 3 times 5. The denominator is 2 times 11. Since they have nothing in common, you can't reduce it. 15 over 22. We're getting there. I hope you're enjoying it a little bit anyway. I like looking for patterns. It's a bit of a game. Looks like we went down 8, huh? And hopefully we're going to go down 8 to 17. Let's see if that's 17, and then we go down 8 to 9, and then we go down 8 to 1, then we go down 8 to -7. Sure enough, we're going down 8 every time. Now, a lot of people are wondering where I get those numbers from. Well, I just look at the difference. Oh, I hope you see the pattern. Look, I know that first one. I already know it's 84 over 91. But look at that, 83 over 91, 82 over 91, 81 over 91, and of course, 80 over 91. And 91 is 13 times 7, isn't it? So my denominator is 13 times 7. And of course, my numerator, if you needed to see it, is 2 times 2 times 2 times 2 times 5. Now, it may not be that obvious to you that this is the prime factorization, but there is nothing in common. And it is something you have to kind of think about a little bit when that's kind of what goes through my head when I'm looking for common factors. Because if you tried to do them all, there are a lot of factors of 80. There's 4 and 8 and 16 and 30, 40, and there's lots of factors, 20. You see what I mean? So anyway, it's 80 over 91, no reducing. Okay, looks like we're alternating between 0.6s and 0.1s and 0.6s. So it looks like we're adding 0.5 and 0.5. We're adding half each time. And if we add a half to 6.1, we're going to get 6.6, aren't we? And then we're going to get 7.1, and then we're going to get 7.6, and so on. So it looks like 6.6 and 7.1. Hopefully I'm going slow enough for you. Don't want to go too fast, although if you've gone this far, I suspect that you're probably not having any trouble. So think about the number that we are changing here. We're changing by the same amount every time. And what did we change by? Well, this is probably the most obvious pair right here. It looks like we added 5, didn't we? And I know you're thinking, wait, didn't we subtract 5? But remember, we're talking about negatives, and these values of negatives are going up as we go. And when we add 5, we get -4. I know you like to, in your head, you like to think, oh, I'm really subtracting 5, but that's not a good plan. You really want to think in terms of what's really happening, which is we're increasing by 5 each time, because that will keep those values in order for you, okay? Trust me, it just makes your life much nicer. That is -4. And in this one, what do we got? It looks like from here to here, it looks like it went up a quarter, doesn't it? If you're not sure where I'm getting this from, you could put the 7.19 and subtract the 6.94 to find out what the difference is, because that's what we're really looking at is differences. And what we did was we added a quarter each time. So 4 from 9 is 5, and I have to borrow 9 from 11 is 2, and the difference was a positive 0.25. And if I add 0.25 to this one, I'm going to get 7.44, aren't I? And if I add 0.25 to this one, I'm going to get 6.69. And you want to check and make sure that these actually work out. If you need to do, if you could grab a calculator, I suppose, and do it, but it's better practice to do it in your head if possible, okay? All right, 53. Okay. Uh, that's interesting. Strange. All right, so what did we do? We went up 0.5, didn't we? That looks the same as what it was before. And that's going to give us 4.08. That's weird. It doesn't look right. No, it doesn't. Oh, such a spaz. Gives us 4.53, doesn't it? And then when we go up 5.5 more, we get to 5.03. I'm just telling you not to use a calculator, and then I mess it up. This one, of course, is 3.03, isn't it? And if we go up 0.5, there we are. So we're adding a half each time, or 0.5 or 5/10. That's the way you're supposed to read that. I prefer to read it as a half or 50%. Anyway, 3.03 and 4.53. And it looks like we've got all of our parts. We went up 0.5 every time. Looks good. Okay, we went up 8. No, we went down 8. We added -8. We added -8. We're actually going down 8. You can think of it as -8, but I think it's mathematically more expedient to add a negative rather than subtracting. But it works either way. So it looks like we're going to get a negative, what, 48? No, not negative 48, negative 44. There we go. Yeah, that is going to be 44. Yep. And over here, it looks like we had a -4. And if we add -8, we get the -12 and so on. And -36 plus -8 is going to be 4, carry the 1, and we get -44. Always good to check it, especially when you're near the end. -4 and -44. Looks good. And looks like we have 1 or 2 more. Okay, let's see. Looks like it went added a -9. Wait, we added a +9. What am I thinking? We added 9, and if we add 9 more, we get to 10, don't we? Oh, that one wasn't so bad. Now, if I add 9 to this one, it's a little harder to see. It's going to be -26. And then if I add 9 more, I get to -17. It's interesting how powerful the AI is in this. My 9s are always the ones that give me the most trouble in adding and subtracting. But anyway, there it is, -26. I added 9. Notice that I am going up in value from -35 to -26. And then I went up 9, I went up 9, I went up 9. And in this one, I'm up at 10. 10. There we go. And our final one, let's see how it looks. Oh, a lovely one. 19 over 25 is 38 fiftieths. I like fiftieths. And then 31 fiftieths. And then this one is going to be 24 fiftieths. I'm just changing them to common denominators. And then 17 fiftieths. And boy, they really want to make us work. So it looks like we're going down 7 fiftieths each time. And that's going to be 10 fiftieths, isn't it? Well, remember, we have to simplify the answer. If you don't simplify it to 1/5, you get it wrong. And make sure you get your 1/5, okay, guys? And I hope you guys get to your 100 and do your mastery. And I'll see you back again. Bye-bye.